In this video tutorial, I'm going to show you how to draw Lewis dot diagrams for molecules with covalent bonds. This video goes with Unit 4.3b on slide number 4. The first molecule I'm going to show you how to draw is water. There are a few molecules that you really should know how to draw very well. Now the first thing I'm going to do is I'm going to count up the total number of valence electrons that are available. Each hydrogen atom has one valence electron, but in the formula, the subscript tells me there are 2. So that gives me a total of 2 valence electrons to work with. I only have one oxygen, and each oxygen has 6 valence electrons, and there's only one. That's a total of 6. I have 8 valence electrons. Now when I look at oxygen by itself and I draw the Lewis dot structure, I have 6 valence electrons. And this is one way that we would draw the Lewis dot diagram. You can see that there's a pair of electrons here, there's a pair of electrons here, but there's unbonded pairs here and here. This means that they need one more electron here to share and one more electron here to share. Knowing that will help me figure out how to place the atoms in relation to one another. So I'm going to put oxygen in the center, and I'm going to put a hydrogen over here and a hydrogen over here. Remember, I had 8 valence electrons to work with. First, I'm going to place 2 here, and that's going to bond that hydrogen to the oxygen. Then I'm going to put 2 there. So I've used a total of 4 electrons. I have 4 electrons left to distribute. I'm going to put a pair here and a pair here. By doing that, I'm giving oxygen access to 8 valence electrons at one time. The hydrogen here and the hydrogen here, they have access to 2 valence electrons, which is perfectly fine because all they need is a duet. They only need access to 2. So this molecule is perfectly correct. All of the atoms have access to all of the electrons they need to be as stable as a noble gas. Let's practice another simple molecule, HCl. Again, hydrogen has 1 valence electron, Cl has 7, so that gives me 8 to work with altogether. This molecule is very easy because hydrogen and chlorine are only 2 atoms. I'm going to put them right next to each other, adjacent to each other. I'm going to put a pair of electrons between them. That forms the bond, and that leaves 6. The remaining 6 I'm going to distribute to the chlorine because chlorine needs access to a full octet. Remember, hydrogen only needs access to a duet. Simple and done. I've used all 8 electrons, and chlorine has an octet, hydrogen has a duet. Let's try a molecule where there's no hydrogen at all. CF4. I have carbon and fluorine. I have carbon with 4 valence electrons, and there's only 1 carbon. And I have fluorine, 7 valence electrons because it's in group 17. There are 4 of them. That gives me a total of 28. Altogether, I'm going to use 32 dots, or 32 electrons. Since there's only 1 carbon, I'm going to put it in the center, and the 4 fluorines I'm going to put all around that central atom. So first I'm going to distribute 8 electrons, or 4 pairs, to create the bonds between the carbons and the fluorines. Remember, I had 32, and I've just used 8. That leaves 24. If I distribute that equally to all 4 of the fluorines, then that allows me to give each of the fluorines 6 electrons each. There's 2, 4, 6, and that fluorine now has 8. 2, 4, 6, and now that fluorine has access to 8. 2, 4, 6, 2, 4, 6. Let's make that one a little bit better, and that one too. And there's 8. And in the center, carbon has access to 8 electrons as well. Remember, 4 of them belonged to carbon, and the rest belonged to fluorine. Each fluorine having 7 dots, sharing 1 electron with the carbon, and carbon having 4 electrons sharing with 4 fluorines. Everyone has access to an octet. Now those were all single bonds. Every time I draw a pair of electrons between atoms, like I did here and here, I can replace those shared electrons, the pair that's shared, with a dash. So I could draw it like this. A dash represents a single bond, and that dash is the same thing as the pair of electrons I drew. It might become preferable to use dashes instead of so many dots. So these two molecules are exactly the same thing. I've just used dashes here instead of a pair of dots to represent the bond. So if I were to do the same thing with CF4, a single bond, but don't forget you have to draw all of those electrons that fluorine has that were not part of the bond. We call them the non-bonding pairs. So I'm drawing in all of the non-bonding pairs of electrons, showing that fluorine is only sharing 1 pair, and it gets to keep the rest of these electrons for itself. Let's do a more complicated molecule, carbon dioxide. Carbon has 4 valence electrons, and there's only 1 carbon. And each oxygen has 6, but there are 2 oxygen. So that gives me 12. Altogether, I have 16. Since I have 1 carbon, I'm going to put it in the center. And I'm going to put an oxygen over here and an oxygen over here. I'm going to put 1 pair here to bond, 1 pair here to bond, and I've used 4. That gives me 12 electrons left. If I divide that equally amongst the 2 oxygens that are left, I can give each oxygen 6 more electrons. There's 2, 4, 6. That gives oxygen its octet. 2, 4, 6, giving that oxygen its octet. But we have a problem. Carbon only has access to 4 valence electrons. It is not happy. So we have to fix that. And I will show you how we will fix that. Alright, so I've created a single bond. And remember, I had altogether 16 electrons. I've used 4, and now I have 12 left. Instead of giving 6 and 6 to each oxygen, I'm going to put another pair of electrons between carbon and oxygen here and here. So I'm going to use another 4, and that gives me 8. If I divide that by 2, I can give each oxygen 4 electrons. 1, 2, 3, 4. And by doing it that way, oxygen still has access to 8 valence electrons. It gets to keep 4 for itself, and the other 4 are shared. The same goes for the oxygen over here. Now, by creating that double bond, the carbon in the center has more shared electrons because each oxygen atom is sharing more than 1 pair of electrons. If I were to draw this molecule using the dashes, it would look like this. Single bond, double bond, single bond, double bond, oxygen, oxygen, and then the non-bonding pairs. Each oxygen is pulling on those shared electrons with equal force in both directions, making this molecule balanced, with the carbon sort of being in the middle in a tug of war with 2 oxygens on either side pulling equally on those shared electrons. Carbon dioxide is probably one of the most difficult molecules to know. Here's another simple one, CH4. Remember, the hydrogen, all it needs is a duet. We've got one carbon with 4 valence electrons. We've got hydrogen, 1 valence electron, but there are 4 atoms. So altogether, we have 8 dots. And we're going to put carbon in the middle. 2, 4, 6, 8, and there's our hydrogens. Checking for happiness, making sure everyone has enough electrons, and they do. If I wanted to draw this more simply, I could just replace all those dots with dashes, and this is a very easy molecule to draw. Alright, one more before we end the slideshow. How about NH3, another one that you should really know how to draw. I've got nitrogen with 5 valence electrons, only 1 atom. And I've got H, 1 valence electron, but there are 3 of them. 8 electrons altogether. Nitrogen is the central atom because it's only 1 of them. Hydrogens all around. And then I will start distributing those 8 electrons. Put a pair between each of the atoms to bond them. There's my covalent bond. And the last pair goes here as a non-bonding pair. Nitrogen has 8. Each hydrogen has 2. And if I wanted to draw it with sticks, there we go. And don't forget, the non-bonding pair needs to be represented as well. I'm going to give you lots more practice in class to keep drawing them, and we'll talk a little bit more about the shapes of the molecules and how the charge is distributed, and you will determine whether or not that molecule overall has a polar or non-polar electron distribution. We'll talk more about that in the next few slides.